Hello there. Welcome back to the long and gentle journey of 100 facts about dinosaurs, where every story is a slow, steady breath, and every image is a doorway opening into Earth's ancient past. Before we continue, take a small moment just for yourself. Let your body relax. Breathe in slowly and exhale softly, just like the layers of Earth that have breathed in and breathed out for hundreds of millions of years, keeping within them every memory of the age of dinosaurs. Today, we arrive at part 10, the legacy that remains, a special chapter. No longer the blazing battles between predators and herbivores. No longer colossal sizes or grand ancient ecosystems. This time, we will listen to something subtler, gentler, a part of the dinosaurs that still lives around you. If you look out the window and see a sparrow perched on the roof, if you hear the morning calls of birds, if you see wings beating softly against the sky, rising light as breath, then that is not just a bird. That is the final heir of the dinosaurs. A small but resilient branch that survived the Great Extinction, carrying within itself the story of 66 million years ago. In this part, we will explore how dinosaurs never truly disappeared, why their DNA still lives quietly within every feather of modern birds, how fossils have told the story of their grand evolution, and above all, how humans first discovered them through dusty excavations, through laboratory nights glowing with light, through questions that had never been answered before. Imagine you are standing on a distant land where the wind sweeps across layers of sediment like the whisper of time. You lean down, touch a small fossil fragment, and in that very moment, you are touching a story that has stretched across millions of years. The legacy of the dinosaurs does not exist only in stone, in bones, in scientific research. It lives in the way we look at Earth, in the sense of awe when we understand that life can vanish, then be reborn, then continue evolving into forms no one could have imagined. So, let your heart open. Let curiosity guide your path, and let every story in this chapter become a small doorway, carrying you from ancient fossil dust to the soft wings soaring through the skies today. Are you ready? Let us begin the journey into the lasting legacy of the dinosaurs. Take a slow breath. Let it fill your chest, your ribs, your quiet inner space. And as you exhale, imagine the air traveling backward through time, past cities, past centuries, past civilizations, past the first human fires, past the ice ages, past the last mammoths, farther and farther, until the breath reaches a world where giant ferns swayed beneath an ancient sun, and the rulers of the planet walked on 2 legs and 3-toed feet. Now open your eyes gently, because in the world you live in today, their descendants are still here, flying above your house, perching on your balcony, singing in the morning, watching you with bright, ancient eyes. You may think you are seeing a bird, but in truth, you are looking at the last living branch of the dinosaur family tree. This is not a metaphor, not poetry, not imagination. This is science, clear, powerful, extraordinary science. And it tells a story far greater than any human myth, a story of survival, transformation, loss, persistence, and rebirth. Let us walk through that story together, slowly, like following footprints left in ancient mud. When people imagine dinosaurs, they picture towering giants with thunderous steps, the terrifying jaws of Tyrannosaurus rex, the sweeping neck of the Brachiosaurus, the armored back of Ankylosaurus, the frilled faces of Triceratops, or the sickle-clawed hunters like Velociraptor. But very few imagine a sparrow, or a pigeon, or the heron standing motionless by a quiet lake. Yet every single one of these creatures is a dinosaur, not metaphorically, but genetically, anatomically, evolutionarily. If you were to draw a family tree of life, the birds would not branch off near reptiles. They would not be distant cousins to dinosaurs. they would be inside the dinosaur branch, nested deep within the lineage known as theropods, the same group that once included Velociraptor, Allosaurus, and T-Rex. And that is the first astonishing truth: dinosaurs never fully vanished. One group survived and learned to fly. Feathers feel soft, fragile, ephemeral. They seem like the very opposite of the dinosaurs we know from museums. Those massive bones locked in stone. But feathers are older than birds, much older. Long before there were sparrows, before there were eagles, before wings existed, there were dinosaurs covered in simple filaments, like wisps of hair, tufts of downy insulation, and later, full feather structures used for warmth, display, or balance. Fossils from China's Liaoning province show this with stunning clarity. Small theropods, some no larger than a chicken preserved in stone, with feathers fanned across their arms and tails. One of them, Sinosauropteryx, had a striped, ringed tail, the first clear evidence that dinosaurs were colorful. Another, Microraptor, had shimmering black feathers with a sheen like a raven's wing. And then there was Archaeopteryx, the ancient icon found in Germany, a creature part dinosaur, part bird, with wings, claws, teeth, and feathers. Feathers were not an invention of birds. Birds inherited them, just as children inherit the stories of their ancestors. If feathers were not enough, the bones themselves reveal the ancestry. Bird skeletons look delicate, hollow, airy, optimized for flight. But these features did not appear suddenly. They evolved step by step across millions of years through dinosaur species that gradually became lighter, faster, warmer. Many theropods had hollow bones, strong wishbones, furculae, elongated arms, three-fingered hands, and advanced lungs that allowed high oxygen flow. All of these features survive in birds today. Look at a chicken's leg bone, or the skeleton of a hawk, or the internal structure of a swallow's wing, and you are looking at the continuation of a dinosaur design. Evolution does not erase. It edits, it polishes, it transforms. Birds are not the replacement of dinosaurs. They are dinosaurs refined by time. Birds have warm blood. They breathe with an advanced air sac system that allows near-continuous airflow. They have high metabolism, fast digestion, rapid growth. These traits did not begin with birds. Studies of bone microstructure show that many dinosaurs, especially theropods, grew quickly and maintained stable body temperatures. They were not cold, sluggish reptiles. They were active, warm-bodied beings. Some ran as fast as modern ostriches. Some flapped their feathered arms while running downhill, perhaps gaining the first spark of lift. And nestled in their chests, they carried a heart and a lung system far closer to a bird's than to any lizard or crocodile. When you feel the heartbeat of a bird, soft but rapid, powerful but light, you are feeling an ancient engine, a 150-million-year-old design, an invention of dinosaurs. Birdsong surrounds us every day, a melody at sunrise, the hoot of an owl at night, the shriek of eagles, the rustling flutter of pigeons. But those sounds are older than humanity. Paleontologists believe that many small theropods could vocalize like birds, using deep, resonant calls, low-frequency hums, or soft coos, created not by vocal cords, but by air sacs and resonating chambers. This means the world of the dinosaurs was not silent. It may have been filled with soft calls between parents and young, territorial songs, courting displays, and rhythmic communication within flocks. Yes, flocks, because many small dinosaurs lived, traveled, and perhaps even hunted in groups. When you hear birds calling today, you are hearing the faint echo of a world long gone, a whisper across millions of years, a voice that began in the age of dinosaurs. 66 million years ago, a brilliant fireball split the sky open, a meteor the size of a mountain. It struck the Earth with a force greater than every nuclear weapon ever built. The world burned, forests collapsed, ash darkened the skies for years. The oceans changed, the climate plunged into cold, the giants fell, the hunters perished. The armored ones, the horned ones, the long-necked ones, all vanished. But a small group survived. They were light, warm-blooded, adaptable. They ate seeds, insects, anything they could find. They sheltered in forests, under shrubs, in cracks of rock. They endured where the giants could not. These survivors were the ancestors of modern birds, the only dinosaurs left after the world ended. Their survival is not just biology. It is a tale of resilience, a reminder that life can be fragile and yet astonishingly strong. When the mammals rose and overtook the land, dinosaurs did not compete. Instead, they claimed the sky. They soared where the world was open. They adapted to every continent. They learned to dive, glide, hover, sprint, migrate, navigate by stars. Today, the descendants of dinosaurs fly over rainforests, tundras, deserts, oceans, skyscrapers, human homes. Their wings slice through the air with the memory of ancient forests beneath them. Birds are the last chapter of a story that began 230 million years ago, when the first small, two-legged dinosaurs walked the earth. Look again at the world around you. The pigeon strutting on the sidewalk, a dinosaur. The hummingbird hovering over a flower, a dinosaur with the fastest metabolism in the world. The hawk circling high above the hills, a dinosaur hunting, as its ancestors once did. The penguin diving in icy waters, a dinosaur that traded skies for oceans. The chicken scratching the ground, a domesticated dinosaur living in your backyard. You live surrounded by dinosaurs every day and rarely notice the miracle. Why does it matter that birds are dinosaurs? Because it changes everything. It connects the distant past to the present. It shows that extinction is not always the end. It reveals the resilience of life. It reminds us that evolution is a story of transformation, not disappearance. And it teaches us to see the extraordinary in the ordinary. When you look at a bird, you are looking at survival incarnate, the last embers of an age of giants, still glowing brightly in feathers and flight. Dinosaurs live on, in the trill of a songbird, in the wings of a swallow, in the shadow of an eagle gliding across the sun, and in the beating heart of every bird. Take one more slow breath, hold it gently, then exhale with the softness of a feather drifting downward. You are living in a world where dinosaurs survived the end of the world, not as echoes, not as fossils, but as living, breathing beings. Their story did not end. It simply changed shape. And now, every time you hear wings flutter, you're hearing the continuation of a miracle that began millions of years before humans existed. Birds are not what came after dinosaurs. Birds are what dinosaurs became. So, let your heart open. Let curiosity guide your path. And let every story in this chapter become a small doorway, carrying you from ancient fossil dust to the soft wings soaring through the skies today. Are you ready? Let us begin the journey into the lasting legacy of the dinosaurs. Most things that live vanish without a trace. Leaves decay, bodies rot, bones crumble, footprints wash away, memories scatter in the wind. But under the rarest of circumstances, something extraordinary happens. A creature dies, and instead of disappearing, it is swallowed by mud, buried by silt, covered by volcanic ash, pressed beneath layers of sediment. Oxygen leaves, decay slows, minerals seep in, atoms replace atoms, and the body turns to stone. This process is slow, patient, delicate, a quiet alchemy performed by the earth. So, when paleontologists uncover fossils, they are not simply finding bones. They are revealing moments of time that refuse to fade. A fossilized bone is a miracle, a whisper from a creature that breathed 100 million years ago. But bones do more than exist. They explain. A single femur, thigh bone, can reveal the dinosaur's size, its age, its growth rate, injuries it suffered, muscles it once held, how fast it could run, how much weight it carried, how it lived, moved, hunted, or fled. The thickness of bone rings, like tree rings, shows how quickly a dinosaur grew, bursting with growth in warm seasons, slowing during harsh ones. The roughness of bone surfaces tells where muscles attached, revealing strength, posture, and movement. A healed fracture shows survival, proof that the animal lived long after an injury, suggesting caregiving or resilience. A bite mark shows battle, the clash between predator and prey, written in scars. When a paleontologist holds a fossilized bone, they hold not merely shape, but a fragment of biography, a fragment of life. If bones are biographies, then footprints are films. A fossilized trackway does not show a moment of death, it shows a moment of life. A step, a run, a chase, a migration, a pause. Tracks can show the speed of the dinosaur, the length of its stride, whether it walked alone or in herds, the direction it was traveling, the type of terrain, whether it was hunted or hunting. Even if it limped, there is a place in Texas where a sauropod's great footprints are followed closely by the footprints of a theropod predator. A chase, a hunt, a heartbeat frozen in stone. Another site in Argentina shows hundreds of tiny tracks, dinosaur hatchlings walking in groups, a nursery recorded forever. Through footprints, we see dinosaurs not as skeletons, but as moving, breathing creatures, crossing rivers, running from storms, exploring their world. Most fossils preserve bones, but on rare, extraordinary days, the earth shares something softer, a patch of skin with hexagonal scales like ancient mosaics, a cluster of feathers, still showing barbs, shafts, and microscopic pigmentation, a horn sheath, a claw covering, a soft tissue shadow, even the outline of muscles. These exceptional fossils show us the patterns on a triceratops hide, the texture of an ankylosaur armor plate, the spreading feathers of a small theropod, the stripes, spots, or iridescent sheen of ancient plumage, the wrinkles of skin around a giant leg. They transform dinosaurs from imagination into reality, from shadows into details. Some skin impressions show that herbivorous dinosaurs had bumps, ridges, or pebbled textures like crocodiles or elephants. Some feathers preserve melanosomes, microscopic pigment cells, revealing color, glossy black, reddish brown, snowy, white, even iridescent blue. Time speaks not only through form, but through color. Every tooth is a weapon, and every weapon tells a story. A curved, serrated tooth shows a predator that sliced flesh like a steak knife. A conical tooth shows a fish-eater who held slippery prey. A flat, ridged tooth shows a plant-eater grinding ferns and cycads. Patterns of wear reveal what dinosaurs ate, how they chewed, whether they bit bone, whether they fed on live prey or scavenged. A broken tooth found embedded in herbivore bone tells of a failed attack, a moment of violence preserved beneath ages of sediment. Claws reveal similar details. Long, grasping claws for climbing, short, hook-shaped claws for capturing prey, wide, weight-bearing claws for walking on mud, spiked defensive claws for protecting nests. These small pieces form the anatomy of entire ecosystems. One of the most touching types of fossils is the nest, a cluster of eggs arranged in a circle, a mother's bones lying above her clutch, baby skeletons curled inside eggs, trampled marks from siblings, layers of nesting grounds used year after year. From nests we learn, dinosaurs returned to the same sites to lay eggs. Some protected their young, some nested in colonies, Hatchlings sometimes stayed near parents. Tiny dinosaurs grew rapidly. Family bonds existed. The famous Maiasaura, good mother lizard, was discovered beside multiple nesting sites, showing mothers feeding their young. This single discovery changed the world's understanding. Dinosaurs were not cold, uncaring reptiles. They were attentive, nurturing, social. Their love, too, was fossilized. Some fossils capture not just bodies, but behavior. Two dinosaurs locked in combat, a predator and prey dying together, a fish swallowing another fish, a dinosaur sleeping with its head tucked under its arm. Like modern birds, these fossils are rare beyond imagination. They are time capsules. One fossil shows a dinosaur crouched like a brooding bird over a clutch of eggs. Another shows a small dinosaur curled like a sleeping chick. Another shows a pterosaur mid-flight, its wings still outstretched. These moments tell a truth. Life, even millions of years ago, was tender, fierce, emotional, and real. Coprolites, fossilized dung, tell us what dinosaurs ate in their final meals. Bones of prey, plant fibers, seeds, shells, insects, even feathers. Microscopic examination shows digestion patterns, gut bacteria traces, and meal composition. One enormous coprolite from T-Rex contained crushed bones from multiple animals, evidence of powerful jaws. Another contained plant stems and seeds, revealing how dinosaurs helped spread vegetation. Even the simplest remains are a map of ancient ecosystems. To read fossils, one must read the earth. Each layer of rock, sandstone, shale, limestone, volcanic ash, clay, is a chapter in a book written by oceans, rivers, deserts, and forests. The Triassic, the Jurassic, the Cretaceous are not just names, they are epochs carved into stone. When paleontologists remove rock layer by layer, they are reading backward through time. Storms, droughts, floods, volcanic winters, meteor impacts, changing climates, and within each layer, fossils serve as footnotes of life's resilience and adaptation. If you hold a fossil in your hand, you are holding time itself. You are touching a memory the Earth chose to preserve against impossible odds. A memory of thunder lizards shaking the ground, feathered hunters darting through ferns, tiny hatchlings calling for their mothers, titanic beasts leaving footprints across floodplains, ancient forests breathing the air of forgotten epochs. Fossils tell us dinosaurs lived, dinosaurs thrived, dinosaurs loved, hunted, ran, slept, fought, and cared. And though their bodies turned to dust, the earth remembered them. Stone is not silence. Stone is memory, compressed, crystallized, eternal. Fossils are the earth's way of saying, I remember the giants who once walked upon me, and I will tell their story as long as there is someone willing to listen. And today, you are the one listening. You are the one opening these ancient pages. You are the continuation of a story written long before humans existed, a story preserved in stone, waiting patiently for millions of years to be heard. In this invisible realm, every creature is made of a code, a script billions of letters long, written in delicate strands of DNA. Dinosaurs had DNA. Birds have DNA. You have DNA. And deep inside that shared molecular alphabet lies one of the most extraordinary truths in natural history. The genetic thread of dinosaurs never broke. It simply changed shape and continues to live on. Let us enter that silent world together, the world where molecules whisper across millions of years. Bones can fossilize, footprints can petrify, feathers can imprint themselves into stone, but DNA is the memory beneath all memories. It is a language, a blueprint, a recipe, a secret archive, a whisper of ancestry. Every living thing carries within itself a biography, written in the tiniest of characters, a biography that stretches backward through time to the first spark of life on Earth. Dinosaurs carried that biography within them, as surely as birds do today. And although time erases the physical body, sometimes miraculously, molecules persist, fragments, patterns, molecular ghosts, enough to tell us life remembers even when the world forgets. Popular films imagine entire dinosaurs resurrected from amber-trapped insects, their blood and DNA perfectly preserved. But reality is gentler, quieter. DNA is fragile. It breaks under heat, radiation, and time. After millions of years, most dinosaur DNA has long deteriorated. And yet, something remains. Not complete genomes, not full sequences, but patterns, chemical hints, fragments embedded in minerals, traces in protein structures, shadow signatures that mirror the DNA of birds. These traces tell us dinosaurs had warm blood. Dinosaurs grew rapidly. Dinosaurs possessed advanced lungs. Dinosaurs were genetically closer to birds than reptiles. And many dinosaur traits live on in modern species. In 2020, paleontologists even discovered possible remnants of dinosaur chromatin, the packaging material around DNA in a fossilized skull. Not enough to clone, more than enough to confirm ancestry. The Earth never fully erased their code. When DNA cannot endure, proteins sometimes can. Collagen, the protein that gives structure to skin, bone, and tendons, can survive astonishing lengths of time under rare conditions. Collagen fragments found inside a T. Rex femur revealed that its closest modern relatives were not crocodiles, but birds. In fact, the collagen patterns of the T. Rex aligned most closely with the modern chicken. A bird you could hold in your hands is more genetically similar to a T. Rex than a crocodile is. Proteins become the bridges where DNA fades. They become the song that continues even after the singer disappears. Feathers are among the most astonishing fossils found. Not only do they preserve shape, they sometimes preserve pigment structures. Inside fossilized feathers, scientists discovered melanosomes, microscopic organelles that hold color. These melanosomes reveal Microraptor had iridescent black feathers. Sinosauropteryx had a banded tail. Anchiornis had red crest feathers. Some dinosaurs had patterns like modern birds. Colors evolved long before true flight. The pigments are not DNA, but they are DNA's artwork, its living expression captured in stone. They prove that the genetic machinery behind feathers today originated in dinosaurs. Color became a thread woven directly through time. DNA and proteins reveal another remarkable truth. Many dinosaurs were warm-blooded. By analyzing oxygen isotopes in bones, the density of growth rings, collagen structure, blood vessel microstructure, scientists discovered that dinosaurs regulated their temperatures, much like modern birds. This warm-blooded nature meant higher metabolism, active behaviors, fast movement, parental care, complex brains, endurance. The DNA of dinosaurs was not cold or reptilian. It burned bright, energetic, rapid, alive. Today, that warmth still burns. In every sparrow's rapid heartbeat, the flame of dinosaur metabolism never went out. If you want to know what a baby dinosaur looked like, you do not need a time machine. You can look at a chick hatching from its egg, an ostrich sprinting across open land, a cassowary strutting with feathers like armor, a hawk tilting its head with predatory precision, a penguin waddling before diving like an ancient swimmer, a rooster scratching the dirt. Their DNA is not similar to dinosaur DNA. It is dinosaur DNA, passed down through unbroken lineage for more than 150 million years. The family tree is not metaphorical. It is literal, molecular truth. Ostriches share skeletal traits with some theropods, down to the shape of pelvis and toes. Chickens possess the dormant genetic pathways for dinosaur-like teeth. Emus carry DNA patterns that mirror ancient raptors. Cassowaries resemble living velociraptors, with feathers instead of scales. Within these birds, the past beats with living wings. A dinosaur egg and a bird egg are separated by millions of years. Yet the architecture is the same. Calcium shell, air chamber, embryonic position, vascular network, protein structure, yolk distribution, eggshell proteins discovered in Cretaceous fossils, match patterns in modern bird eggs. The blue-green pigmentation of some dinosaur eggs suggests parental care, just like birds that camouflage or display their nests. Embryos show tucked head posture, curled body, limb arrangement. These movements are controlled by DNA. The same choreography repeats today inside every egg laid by a bird. When a chick wiggles inside its shell before breaking free, it is enacting a ritual older than human civilization by 100 million years. When the Chicxulub asteroid darkened the skies and ended the Mesozoic world, most dinosaurs perished, but genes, tiny, persistent, tenacious, did not. They retreated into the survivors, small-bodied theropods, birds with flexible diets, species able to hide, adapt, wait, animals whose DNA encoded resilience. From those survivors emerged every bird species today: eagles, crows, parrots, owls, hawks, songbirds, seabirds, hummingbirds, ostriches, penguins. The genetic flame of dinosaurs passed from one world into the next. The dinosaurs did not end. They transformed, and DNA is the ledger where that transformation was written. 9. DNA as the story that outlives extinction. The astonishing truth of DNA is this: extinction ends bodies, not stories. A genome is a story written over generations, and birds carry chapters from ancestors who roamed forests of ferns and deserts of ancient dunes. Within the DNA of a robin are hints of theropod limb structure, dinosaurian lung systems, ancient cranial architecture, feather pattern genes, the echoes of fierce hunters. Within the DNA of a falcon are traits for binocular vision, embedded predatory instincts, muscle mapping from ancient raptors. Within the DNA of a chicken lie dormant pathways that once shaped reptilian teeth. Within the DNA of an ostrich are footprints of colossal, running theropods. DNA is the thread. Species are the fabric. Extinction may unravel the fabric, but the thread remains. Take another slow breath. Let it settle. Listen to what the universe tells you. In the quiet, the story of dinosaurs was not buried in the earth. It was carried into the future, cell by cell, feather by feather, wing by wing. Every bird that takes flight is a living continuation of a world older than imagination. Every heartbeat of a bird is the heartbeat of a dinosaur. Every feather is a page written by ancient genes. Every migration is a journey first taken when continents were still drifting apart. Every song is a quiet echo from the age of giants. Dinosaurs do not live in the past. They live in the present, in the skies, on branches, across oceans, woven into the fabric of life. And when you look at a bird, you are not seeing the aftermath of extinction. You are seeing survival, evolution, continuity, persistence, transformation, memory. you are seeing the DNA of dinosaurs still alive. Now imagine a human figure, small, against the immensity of the landscape, kneeling in the sand, brushing away grains of dust that have hidden something for more than 100 million years. This is where our journey begins. Not in the age of dinosaurs, but in the age of humans, when we finally learned how to listen to the stories written in stone. For the truth is simple, yet profound. Humans did not discover dinosaurs. The earth revealed them, slowly, patiently, to those willing to kneel and listen. Let us walk through that story, the story of humanity, discovering the deepest memory of the planet. Long before paleontology existed, long before science learned to read fossils, humans still found enormous bones buried in valleys and cliffs. But without the language of science, they used the language of imagination. Ancient Greeks found giant bones and believed they were the remains of the Titans, the legendary children of Earth. Chinese villagers discovered immense femurs and saw dragons curled beneath the mountains. Native American tribes found great vertebrae and spoke of thunderbirds soaring above storms. In medieval Europe, fossilized horns of Triceratops were mistaken for the bones of mythical griffins guarding treasure. Humanity sensed something colossal lived before them, but they did not yet know its face, nor its name. The earth spoke, and humans interpreted in myth. By the 1600s and 1700s, scholars began to question myths. The earth was old, older than scripture, older than kings. Strange bones were not dragons or giants, but the remains of real creatures. Still, the idea of extinction was unthinkable. Why would an entire kind of animal vanish? It was not until Georges Cuvier, a French naturalist, studied prehistoric bones in the late 1700s that humanity learned a truth nature had known all along. Species can disappear. Entire worlds can end. Extinction became a scientific reality, and suddenly the fossils around us were not strange curiosities, but messages from lost ages. In the early 1800s, a British geologist named William Buckland described strange, massive teeth, unlike any living animal. They belonged to Megalosaurus, the first dinosaur ever scientifically named. A few years later, Mary Ann Mantell discovered a fossil tooth embedded in a stone by the roadside. It resembled the tooth of an iguana, but many times larger. Her husband, Gideon Mantell, studied it and named the animal Iguanodon. Then appeared Hylaeosaurus, armored and formidable, 3 creatures from another world, 3 windows into deep time. The word dinosaur had not yet been coined, but a new world was being uncovered, piece by piece. Humanity had begun listening to the Earth's deepest memories. In 1842, British scientist Richard Owen looked at the fossils of Megalosaurus, Iguanodon, and Hylaeosaurus and recognized something astonishing. They were not giant lizards. They were part of a distinct ancient lineage, unlike anything alive today. He gave them a name, Dinosauria, fearfully great lizards. With a single word, the ancient, vanished world of the Mesozoic became imaginable, and the human journey of discovery accelerated. In the late 1800s, 2 paleontologists, Edward Drinker Cope and Othniel Charles Marsh, began one of the most dramatic rivalries in scientific history. They raced across the American West, digging, blasting, uncovering, competing to find the most dinosaur species. Their rivalry was intense, even destructive, yet it led to the discovery of Stegosaurus, Triceratops, Diplodocus, Allosaurus, Apatosaurus, and dozens more. A golden age of fossil discovery, fueled by obsession, ambition, and the earth revealing its secrets. To those who pursued them relentlessly, the dinosaurs were returning, not to life, but to human knowledge. By the early 1900s, great museums began displaying full skeletal mounts. The American Museum of Natural History, the Smithsonian, the Natural History Museum of London, the Field Museum. Visitors walked beneath the towering ribs of Diplodocus and Apatosaurus. They stood face to face with Tyrannosaurus rex. For the first time in human history, children stared in awe. Scientists speculated on posture, behavior, ecology. Artists painted vivid prehistoric landscapes. Dinosaurs became part of culture, icons of deep time, symbols of lost worlds. The Earth's ancient memory had entered the human imagination. For many decades, dinosaurs were depicted as sluggish, cold-blooded reptiles. Then, in the 1,960 seconds and 1,970 seconds, a revolution began. John Ostrom discovered Deinonychus, a fast, agile, bird-like predator. This discovery changed everything. Scientists realized that dinosaurs were active, were warm-blooded or near warm-blooded, traveled in herds, hunted cooperatively, cared for their young, were far more intelligent than once believed. This era became known as the Dinosaur Renaissance. Dinosaurs were no longer monsters. They were athletes of their world, complex, dynamic, vibrant creatures. Human understanding evolved as Earth's memory grew clearer. Today, paleontology is not just brushes and shovels. It is lasers, CT scans, 3D modeling, molecular analysis, AI reconstruction. Scientists can now scan fossil bones for microscopic cells, reconstruct dinosaur muscles digitally, map ancient blood vessels, simulate dinosaur movement on computers, analyze pigment structures in fossil feathers, determine growth rates through bone histology, decode fragments of ancient proteins. The Earth is being read with tools sensitive enough to hear whispers buried in stone. In labs across the world, ancient life rises again, not in flesh, but in knowledge. We know how dinosaurs breathed, hunted, nested, migrated, evolved, and died, because technology lets us read the silent archive with ever greater clarity. Dinosaurs lived for 165 million years. Humans have existed for a fraction of that time, yet we have become the custodians of their memories. Every fossil pulled from the ground is a responsibility, a fragile piece of the Earth's diary. When scientists restore a skeleton, when artists paint ancient forests, when museums display these giants, humans become storytellers. For creatures that can no longer speak, we give voice to beings who once ruled the world. And as we do, we learn more about ourselves, our curiosity, our humility, our longing to understand our place in time. The human journey to discover dinosaurs is also the journey to discover the deep past of our own planet. Why do humans care so deeply about creatures that died millions of years ago? Perhaps because dinosaurs remind us of the fragility of life, the immensity of time, the beauty of change, the inevitability of extinction, the miracle of survival, the power of memory. In a universe where everything ends, dinosaurs show us that stories can endure. They show us that even after worlds vanish, traces remain in stone, in genes, in imagination. When we uncover a fossil, we are not just discovering a creature, we are discovering a lesson that every age ends, but every age also teaches, and the Earth remembers everything. Dinosaurs lived, they thrived, they disappeared, and now humans, tiny, curious, fragile humans, are the ones who hold their memories. Our journey to discover dinosaurs is the Earth's journey, to reveal itself to us. We are the final page in the story of giants, and through us, their story continues. All around you, beneath continents, deserts, mountains, riverbeds, beneath cities and forests, beneath oceans long dried or newly formed, lies a truth older than humanity itself. Dinosaurs lived, and the earth kept the evidence. Everywhere. To know dinosaurs lived, we do not rely on imagination, or stories, or legends. We rely on evidence, clear, physical, scientific, etched into the earth like memories that refuse to fade. This is the story of how we know, how we truly know, how we read the world, the same way one reads a sacred, ancient book. Bones are the most iconic evidence of dinosaurs. Colossal femurs thicker than tree trunks, skulls with horns, frills, serrated teeth, vertebrae like stone wheels, ribs as tall as a standing human. But dinosaur bones are not simply shapes. They are architecture. They reveal posture, movement, weight, distribution, muscle placement, running, speed, diet, growth rate, age, behavior. A single vertebra shows the attachment points of tendons. A single thigh bone reveals stride length. A single tooth shows the feeding strategy of a hunter. Inside bones, under a microscope, thin slices reveal growth rings, like trees. Wide rings show warm seasons with abundant food. Thin rings show harsh conditions. Some dinosaurs grew fast, some slowly. Some paused their growth during droughts or winters. Bones tell not only that dinosaurs lived, but how they lived. If bones are the bodies of dinosaurs, footprints are their movements. A footprint is not a moment of death. It is a moment of life. A step, a run, a slip, a chase, a migration. Dinosaur trackways reveal speed, stride length, herd movement, predator-prey interactions, social behavior, migration paths. Even if an animal was injured, in Texas, a sauropod's tracks are followed by the prints of a theropod, a predator stalking its prey across a muddy riverbank millions of years ago. In China, thousands of tiny hatchling prints document a dinosaur nursery, children running, stumbling, exploring. In Argentina, deep parallel grooves show the movement of massive herds. Each trackway is a film capturing the choreography of ancient life. On days when luck becomes a partner of science, the earth reveals something other than bone. Skin impressions, scale patterns, feather imprints, claw sheaths, horn coverings, muscle shadows. These rare fossils show what dinosaurs looked like. Not imagined, but real. Some show skin textures like crocodilian scales, pebbled mosaics, hexagonal patterns, ridged armor. Others show feathers, complex, delicate structures, preserved by ash or fine sediment. These fossils show color patterns, insulation, display structures, early wings, evolution of flight. The ancient world gains texture, shape, warmth, and color. Time becomes visible. Fossil eggs are among the most intimate evidence we have. They show nesting grounds, brood care, embryonic development, parental protection, colony behavior. The nests of Maiasaura show mothers remained with their young, feeding them, protecting them. Oviraptor fossils, once thought to be egg thieves, are now known to be parents, found frozen in brooding position wings spread over their nests, protecting their babies in their final moment of life. Inside fossilized eggs, embryos lie curled in familiar poses, the same posture seen in modern bird embryos. These fossils whisper, dinosaurs were parents, not monsters. Fossilized dung coprolites may sound unglamorous, but they are windows into ancient diets. Coprolites reveal what dinosaurs ate, how they digested, stomach contents, prey species, plant varieties, growth patterns of vegetation, predator-prey relationships. A T. Rex coprolite shows crushed bones, splintered by its powerful jaws. A hadrosaur coprolite contains plant fibers and even traces of ancient gut bacteria. A sauropod coprolite contains seeds, indicating that these giants helped spread vegetation. Like living forests on legs, even digestion becomes evidence. Fossils do not appear randomly. They occur in geological layers, each layer a chapter of Earth's long biography. Triassic, Jurassic, Cretaceous. Rock layers show ancient riverbeds, floodplains, deserts, volcanoes, inland seas, forest floors. By reading the layers, we read time. By dating volcanic ash within layers, we learn precise ages. By examining chemical signatures, we detect ancient ozone conditions, temperatures, rainfall, atmospheric composition. The Earth wrote the story of dinosaurs in layers of stone. Scientists simply learned how to read the language. Some fossil formations capture dramatic moments. A sudden volcanic eruption, a sandstorm that buried entire herds, a drought that gathered dinosaurs at a shrinking watering hole, a flash flood that swept dozens into a ravine. Bone beds reveal social groups, herding behavior, predator-prey ratios, disease outbreaks, catastrophic events. In one famous site, thousands of Centrosaurus fossils lie tangled together, victims of a massive flood. These mass graves are not just evidence of death, but evidence of life lived together. Modern paleontology is not just digging, it is chemistry, physics, biology, geochemistry, radiometric dating, electron microscopy. Scientists examine oxygen isotopes in bones to infer temperature, carbon isotopes to understand diet, rare earth elements to track fossilization, mineral replacements as timestamps, radioactive decay to calculate age, microscopic bone cells for growth patterns. At the cellular level, some fossils preserve blood vessel shapes, osteocyte outlines, collagen remnants, protein fragments. These microscopic relics confirm life at a scale bone alone cannot show. Even behaviors can be inferred using biomechanical modeling, 3D reconstructions, muscle mapping, wind tunnel tests for feathered dinosaurs, stress tests on bones, computer simulations of gait. Scientists can determine how fast dinosaurs ran, how they held their tails, whether they could swim, how they used their claws, how they balanced their bodies, how they breathed, how their lungs expanded, how far they migrated, how they hunted, how they displayed for mates. Dinosaurs walk again, not in flesh, but in physics. Take one more slow breath. Then picture this: a tiny bone in a museum drawer, a footprint stamped into ancient mud, a feather frozen in ash, an egg curled with life that never hatched, a coprolite revealing a final meal, a nest buried by time, a skull preserved through catastrophe, a fossil bed stretching across a desert. All of these are memories, not human memories, but the Earth's memories, and together they form a truth as solid as stone. Dinosaurs lived, dinosaurs thrived, dinosaurs walked, ran, hunted, nested, migrated, and roared across worlds older than imagination. We know they lived, not because we imagined them, but because the earth remembers them with exquisite, undeniable detail. The earth wrote their story in bones, tracks, feathers, eggs, chemistry, and stone. And humans, thousands of generations later, finally learned how to read it. Dinosaurs lived, and because the earth refuses to forget, we will always know.